Ever since the first studies of the Great Pyramid in Egypt have been made,
The Great Pyramid of Giza has stood for over 4,500 years. It has survived wars, earthquakes, centuries of looting, and the relentless scrutiny of the world's most brilliant minds.
My approach to the question was, where are the quarries? What kind of a ramp can you get from the quarry to the pyramid in a functional slope?
Egyptologists have studied it. Engineers have modeled it. Historians have debated it. And for over 150 years, the academic world has told you the same answer. Slaves and workers, copper tools, wooden ramps, and brute force. But here is what they never told you. Every single time someone ran the actual numbers, the real measurements, the hard engineering data, the geological evidence, the answer that came back didn't fit, not even close. And for over a century, those numbers were quietly filed away in separate academic departments, never forced to sit in the same room at the same time. Until now. Because in 2024, something unprecedented happened. An AI system, one with no career to protect, no academic reputation on the line, no professional reason to defend a theory it didn't build, was given unrestricted access to every piece of data ever collected on the Giza plateau, every archaeological survey, every construction analysis, every geological report, every mathematical study, all of it at once.
In between the blocks were stuffed lots of limestone chippings mixed with a huge dollops of mortar. And it's set just like modern concrete.
And what it found didn't just challenge the mainstream narrative. It proved the mainstream narrative was never actually complete. Stay with me, because by the end of this video, you are going to look at the Great Pyramid very differently. And you are going to have a question that no textbook has ever given you a satisfying answer to. The official story and its cracks. Let's start with what we've been told, because the official story isn't entirely wrong. That's what makes this so complicated. According to mainstream Egyptology, the Great Pyramid was built around 2560 BCE, under the reign of Pharaoh Khufu. The workforce was not made up of slaves. Modern archaeology has actually confirmed that. Excavations near the Giza plateau uncovered entire villages built for organized teams of skilled workers. There are hieroglyphic records. There are papyri documenting the logistics of transporting stone. Copper tools have been found at the site. The evidence for large-scale human labor on this project is real, documented, and not in serious dispute. So let's be clear about that. Nobody credible is arguing that ancient Egyptians had nothing to do with the pyramid. That's not what this is about. What this is about is the numbers, because the numbers have never added up. And for over 150 years, the academic world has been explaining those numbers one at a time, in isolation, hoping you wouldn't ask them to explain all of them together. Here's what the numbers actually say. The base of the Great Pyramid is leveled to within 2.1 centimeters across a span of 230 meters. Read that again, slowly. Across a distance of nearly a quarter of a kilometer. Across bedrock. Across a massive construction site with thousands of workers. The variation from a perfectly flat plane is less than the width of 2 fingers. That is a precision deviation of 0.009%. Modern construction standards for large-scale structures allow for deviations of up to 0.1%. The pyramid exceeds that standard by an order of magnitude. And the official explanation for how that was achieved? Water-filled trenches, wooden squares, and plumb lines? Ask yourself honestly, does that explanation satisfy you? Because it didn't satisfy the engineers who ran the numbers either. Now let's talk about orientation. The 4 sides of the Great Pyramid are aligned to true north with an error of just 3 arc minutes. 3 arc minutes. That is the kind of alignment precision that today requires advanced surveying instruments, satellite positioning systems, and carefully controlled astronomical observation. And this was supposedly achieved by a Bronze Age civilization, using naked-eye star observation and basic geometry. Every experimental attempt to replicate this precision using the proposed ancient tools has failed. every single one. The margin of error in those experiments is measured in centimeters, not millimeters. The pyramid is measured in millimeters. And then there is the timeline. The construction of the Great Pyramid is typically attributed to a 20-year window. That sounds like a long time until you do the math. The structure contains an estimated 2.3 million stone blocks, many weighing between 2.5 and 15 tons. To place all of them within 20 years, workers would have needed to position approximately 300 multi-ton blocks every single day. That is one block every 2 minutes during daylight hours, with no breaks, no accidents, no learning curve for 2 straight decades. No other construction project in the ancient world, not the Colosseum, not the temples at Angkor Wat, not the Colossus of Rhodes, demanded anything close to this level of sustained, flawless precision under those conditions. Now here is the question mainstream Egyptology has never been forced to answer. How do all of these factors exist simultaneously within the same project, built by the same workforce, using the same technology? Because the answer, ancient Egyptians were resourceful and organized, covers the first anomaly, and maybe the second. But does it cover all of them at the same time, in a single coherent explanation? That is exactly the question that Grok AI was built to answer. What Grok AI actually found. In 2024, Elon Musk's Grok AI system was given something no human researcher had ever truly been given. Not because the data didn't exist, but because the academic world was never structured to use it this way. Grok was handed the complete body of available research on the Giza pyramids, over a century of archaeological surveys, construction analyses, astronomical alignment records, geological assessments, mathematical studies, and tool-marked databases, all of it simultaneously. And it was given one directive: analyze the data without theoretical commitment, without professional bias, and without any obligation to protect existing interpretations. What came back was not a reinterpretation of one anomaly. It was a pattern, a systemic pattern across multiple independent categories of evidence, all pointing in the same direction. And that is a very different thing. Let's start with the mathematics, because this is where the results become genuinely difficult to dismiss. The ratio between the Great Pyramid's base perimeter and its height approximates 2 pi, the fundamental constant associated with circles, with an accuracy within 0.05%. This single relationship has been debated for decades. Skeptics argue it could be coincidence, and in isolation, that argument has some merit. But Grok didn't find one relationship. It found 7. Additional ratios connecting the pyramid's height, base, and slope angle correspond to the golden ratio phi, a mathematical constant that wasn't formally described until ancient Greek mathematics, more than 2,000 years after the pyramid was built. And these 7 independent dimensional relationships all appear within the same structure. Grok calculated the probability of all 7 arising randomly in a structure built through trial and error, without advanced mathematical knowledge. And that probability is statistically effectively 0. But even that discovery is secondary to what came next. When the pyramid's height is multiplied by 43,200, the result closely approximates the Earth's polar radius. When the base perimeter is multiplied by the same number, the result approximates the Earth's equatorial circumference. The number 43,200 corresponds exactly to the number of seconds in 12 hours, a fundamental unit of time. Let that sit for a moment. The Great Pyramid appears to encode an accurate model of the Earth's dimensions using a time-based scaling factor. Independent surveyors and engineers who reviewed Grok's methodology confirmed that the probability of this 3-dimensional correspondence arising by accident within a single structure is, in their words, effectively 0, which means whoever designed this structure knew the dimensions of the Earth. Not approximately, not by rough estimate, with the precision of a deliberately chosen mathematical constant. According to every accepted historical record, that knowledge should not have existed in 2560 BCE. Eratosthenes, the Greek scholar credited with first calculating the Earth's circumference with reasonable accuracy, didn't do so until approximately 240 BCE, more than 2,000 years after the pyramid was supposedly completed. So the question is no longer just how the pyramid was built. The question has become, who had the knowledge to design it? The evidence carved in stone, mathematical relationships, no matter how statistically compelling, still live in the realm of numbers. A determined skeptic can always argue measurement interpretation. But what Grok found next is not a matter of interpretation. It is carved directly into granite, and granite does not lie. Grok's analysis cross-referenced toolmark databases with the granite components of the pyramid, specifically within the internal chambers, the sarcophagus in the king's chamber, and the massive relieving chambers above it. These elements were constructed from granite transported from Aswan, more than 800 kilometers from Giza. Moving them was already an extraordinary logistical achievement. But that's not where the real problem begins. The problem begins with a question of basic physics. Granite contains quartz crystals that rank 7 on the Mohs scale, the standard system for measuring mineral hardness from 1 to 10. Copper, the hardest metal available in Bronze Age Egypt, ranks between 2.5 and 3 on that same scale. This is not a matter of historical debate. It is a fundamental property of materials. A softer material cannot cut through a harder one in a straight, consistent manner. What happens instead is deflection. The tool is pulled off course when it encounters harder mineral inclusions within the stone. The result is variable depth cuts, irregular surfaces, and inconsistent trajectories. Modern experiments attempting to saw granite with copper tools and abrasive sand produce exactly these results, every time, without exception. Now here is what Grok's analysis found in the pyramid's granite components. The cuts maintain uniform depth and straight trajectories, even as they pass through boundaries between minerals of different hardness within the same block. They do not deflect, they do not vary, they cut through the transitions between quartz and feldspar as though those transitions do not exist. Copper tools with abrasive sand cannot do that. The physics don't allow it. The most damning piece of physical evidence is an object called the Petrie core. It is a cylindrical granite sample recovered from the Giza site and first analyzed by British engineer and archaeologist Flinders Petrie in the late 19th century. Running along its surface is a helical groove, the unmistakable signature of tubular drilling. Petrie measured the feed rate of the drill, the distance the tool advanced into the stone with each full rotation. The figure he derived implies pressure and rotational speed far beyond anything achievable through ancient manual drilling methods. More than a century later, mechanical engineer Christopher Dunn re-examined the same core sample. His conclusion was stark. The cut characteristics are consistent with one of two possibilities: a diamond-tipped drill or an ultrasonic vibration mechanism that transfers energy directly into the stone. Neither of these technologies appears anywhere in the known archaeological record of ancient Egypt. Not in a single tomb, not in a single text, not in any workshop excavation. Nowhere. Grok compared the complete range of granite tool marks from the pyramid against a database of modern cutting methods: diamond saws, high-speed rotary systems, water jet cutting, ultrasonic machining. The closest matches were to modern techniques, not ancient ones. And this is the conclusion the system produced. Specific granite components within the Great Pyramid were shaped using a method that current science cannot classify within the historical context of ancient Egypt. The tools attributed to the builders cannot account for what remains in the stone. Something else produced these results. And that something has left no trace anywhere else in the entire archaeological record of the civilization credited with building this monument. Think about what that actually means. You have a civilization that, according to the record, built magnificent temples, created elaborate tomb art, developed one of the world's great writing systems, mastered agriculture and medicine and astronomy. They left evidence of all of it: tools, pigments, written records, workshop debris. But the tool that cut the king's chamber granite? Nothing. No prototype, no workshop, no intermediate version, no mention in any text. It is as if the capability appeared, was used once, and vanished entirely. The silence in the archaeological record. Now we arrive at the most uncomfortable part of this entire analysis. Because what Grok identified isn't just a collection of anomalies, it is the shape of what is missing. Think about every major area of human technological development: pottery, metallurgy, agriculture, writing, architecture. In every single one of these fields, archaeologists can trace the progression: crude early attempts, gradual refinement, intermediate failures, increasing sophistication across clearly identifiable stages. The record shows you the learning curve because the learning curve always leaves evidence. The construction of large stone monuments in Egypt should follow that same pattern. And for a brief moment, it appeared to. The step pyramid at Saqqara, built under Pharaoh Djoser, represents the earliest known large-scale stone construction in Egypt. It is impressive, but it is also clearly a first-generation attempt, blocky, stepped, built by a civilization learning what stone can do. Just 3 generations later, the Great Pyramid of Giza appears, with full precision, with perfect orientation, with its mathematical encoding already complete, with granite components cut to tolerances that copper tools cannot achieve. There are no intermediate structures, no archaeological layer of almost Giza precision, no record of a failed large pyramid that came close but didn't quite achieve the tolerances. No evidence of the process that took a civilization from the step pyramid to the Great Pyramid in what amounts to, historically speaking, a heartbeat. Capability appears without any observable developmental precursor, and then the geological evidence makes the timeline even harder to accept. Geologist Robert Schoch of Boston University conducted a detailed analysis of the weathering patterns on the Sphinx and its surrounding enclosure walls. This is important because stone weathering is not a matter of interpretation. Different types of weathering leave distinctly different physical signatures. Wind and sand erosion produces horizontal striations. Rainfall erosion produces deep vertical channels. The Sphinx enclosure walls display deep vertical erosion channels, the signature of prolonged significant rainfall. And the last time North Africa received rainfall sufficient to produce this kind of weathering was between 7,000 and 9,000 BCE, thousands of years before dynastic Egypt even existed as a civilization. When Schoch presented these findings at the Geological Society of America conference in 1991, the room of professional geologists did not reject his technical analysis. Not one of them challenged the geology. The pushback came entirely from Egyptologists, specialists in ancient Egyptian culture and history, not in rock weathering mechanics, who argued that the conventional construction date had to be preserved. Grok's geological analysis tested the mainstream counter-argument directly. The argument holds that the Sphinx's vertical erosion was caused by wind and sand, not rain. So Grok compared the Sphinx weathering patterns against confirmed dynastic structures on the same Giza plateau, structures that were built later, exposed to the same environment, the same wind, the same sand. Those later structures show horizontal wind-driven erosion. The Sphinx shows vertical, water-driven erosion. 2 structures, same location, same environmental exposure across millennia, completely different weathering signatures. There is only one variable that can explain that difference: age. The Sphinx is significantly older than the structures built around it, and if that is true, it means the Giza Plateau was a site of monumental construction before dynastic Egypt existed as a historical entity. This is the moment where two independently verifiable measurements come into direct conflict: the accepted construction date and the weathering signature. Both cannot be correct at the same time. If the construction date is right, the erosion pattern should not exist. If the erosion pattern is right, the construction date is wrong. One of them has to give, and for the last 3 decades, the answer to which one gives has been determined not by evidence, but by which academic field had more institutional authority. What Grok's conclusion actually means. Here is something that is absolutely critical to understand about Grok's analysis, because it is the point that separates honest inquiry from sensationalism. Grok does not claim to know who built the Great Pyramid. That answer does not exist within the available data, and the system is precise in recognizing that boundary.
See, we're leaving a lot of metal and very little stone is flaking out.
This is not a video claiming aliens built the pyramids. That is not a conclusion the evidence supports. And any analysis that jumps to that conclusion is doing the same thing the conventional explanation does, reaching past the data to land on a preferred answer. What Grok produced is something more valuable and more intellectually honest than a dramatic conclusion. It produced a threshold, a clearly measured dividing line between what the conventional explanation can account for and what it cannot. On one side of that line, the established evidence of dynastic Egypt stands intact. The worker villages, the papyri, the administrative records, the copper tools found in archaeological context, the evidence of organized labor on the plateau. None of that disappears. None of it is contradicted. On the other side of that line are equally real, equally measurable observations that the conventional model cannot absorb. Leveling precision beyond modern construction standards. Astronomical alignment beyond the measurement capabilities attributed to the builders. Mathematical encoding of Earth's dimensions appearing thousands of years before its formal discovery. Granite cutting traces inconsistent with copper tools. No developmental precursor in the construction sequence, and a direct geological conflict between the accepted construction date and the weathering evidence of the Sphinx. These two bodies of evidence both exist, they are both real, and they cannot be fully reconciled within a single coherent explanation. Not yet. From this boundary, Grok identifies 3 legitimate hypotheses, not conclusions, hypotheses. First, dynastic Egyptians possessed a far more advanced construction technology than what survives in the archaeological record. Tools or methods reserved for royal projects, never widely distributed, disappearing with the dynasty that used them. This would explain why the evidence exists in the pyramid, but nowhere else. Second, the pyramids were built by dynastic Egyptians using knowledge inherited from an earlier culture. A civilization that existed during the humid Sahara period, when North Africa supported larger and more complex populations than recorded history currently acknowledges. A culture that possessed the mathematical and engineering knowledge passed it forward and then disappeared from the record. Third, the geological evidence is correct. The Giza Plateau was the site of monumental construction long before dynastic Egypt, carried out by a civilization for which no confirmed historical record currently exists, one that may have been erased not by conspiracy, but by time, flooding, climate shift, or simple archaeological inaccessibility. None of these 3 hypotheses is fully excluded by the physical evidence. None is fully confirmed by it, but all 3 are more consistent with the complete data set than the explanation that has dominated academic discourse for over a century. And that matters enormously, because the conventional explanation is not a conclusion fully secured by evidence. It is a framework sustained by internal consistency within specialized academic fields, and by the fact that no system had ever been given both the resources and the incentive to place all categories of evidence on the same table simultaneously, and demand that they all hold together at once. Grok did that, and the framework didn't hold. The question that can't be deferred, The Great Pyramid still stands. That has not changed. The measurements embedded within it have not changed. The marks left in the granite have not changed. The weathering on the Sphinx has not changed. These are physical facts. They were true before this analysis, and they remain true now. What has changed is that for the first time, a system with no professional stake in the outcome looked at all of it simultaneously and said clearly and without ambiguity, the existing explanation is insufficient. Not wrong about everything. Insufficient. And in science, those two words mean very different things. Insufficient means the framework explains part of the picture, but not all of it. And when you are dealing with a structure that may be one of the most precisely engineered objects in human history, explains part of it, is not good enough. Here is the question this analysis leaves you with. And it is a question worth sitting with, because it does not have an easy answer. If the knowledge required to design the Great Pyramid was already complete before the first stone was placed, if there is no learning curve, no developmental record, no archaeological trail leading to it, then where did it come from? What civilization? What culture? What body of knowledge produced a design that encoded the Earth's dimensions with a precision that humanity would not officially rediscover for another 2,000 years? That question has existed in the academic record for over a century. It has been deferred, compartmentalized, and quietly set aside every time it threatened to destabilize the mainstream narrative. It can no longer be deferred. And maybe that's the most significant thing about what just happened. Not that an AI found the answer, it didn't, but that an AI for the first time refused to let the question be treated as settled. It looked at the evidence, all of it, and said plainly and without political consequence, we do not actually know. We have assumptions, we have frameworks, we have a very compelling story backed by real evidence. But knowing, that is something different. The pyramid stands. The question stands with it. And for the first time in a very long time, the academic world no longer has the luxury of pretending otherwise. If this video made you think differently about what we actually know versus what we've simply been told, hit that like button and make sure you're subscribed, because we are just getting started.